Well, hello everyone. I'm really excited to be moderating today's panel on large language models. I'm Chris Van Pelt, a co-founder of Weights and Biases, and I'd like to start by just going around the room and having the panelists introduce themselves and share a little bit about what they're working on.
Yes, so I'm Jay Alamar. I work at Cohere, which is a provider of large language models and NLP tools for developers. I'm director and engineering fellow, and I help the developer community and enterprises figure out the best use cases for these models. Just connect the dots between model capabilities and, let's say, business use cases. I'm also just fascinated about machine learning and NLP as a whole. So I maintain an active blog that explains a lot of these concepts between transformers, BERT, GPT models. My latest write-up was on stable diffusion. Excited to be here.
Very cool. Excited to have you, Jay. Hanlon.
Yeah, great to meet you all. My name's Hanlon Tang. I'm the CTO and co-founder of Mosaic ML. We build software and tooling that enables companies to easily train their own large AI models, such as LLMs, on their own data inside their secure environments. We built a stack that sort of makes training these large models for quote unquote just work. I'm a computational neuroscientist by training, so I have been working with neural networks, both artificial and live, for many years now.
Very cool. Last but not least, Boris.
Yeah, I'm Boris Teima. So what I do, I'm continuously learning about how to use those language models and training new models. I learn a lot with your blogs, Jay, by the way, but the illustrated transformer and all. I don't know how many times I opened it until I actually understood what it how it really worked. But I really like that. And I at the moment I work a lot on generative AI, in particular images like Dalimini and now Crayon. Have a lot of fun on writing like dumb things and have some image coming up. So that's what I do now.
Very cool. It's been a heck of a year for AI, ML, and especially these large language models. Boris, I remember when you released Crayon. This was before Stable Diffusion, before ChatGPT, and kind of all of this peak type. I guess a question for the group. Clearly there's a lot of hype around AI, ML in general, and these large language models. Is this is it overhyped? How do we feel? What's the temperature on kind of the general sentiment here towards what we've all been doing for many years, but now the rest of the world is like really excited about?
I guess I can kick it off. I mean, I usually try to avoid the hype as much as possible and focus on the business and the use cases, but it's hard to not get excited. We work with a lot of startups and tinkerers out there, and yeah, it's hard not to get excited by the absolute creativity that these folks are now building, and we have almost the privilege of observing. I mean, folks bring language models to motion, AI powered 3D design tools, financial customers deploying them today. It's even though I try to stay grounded in use cases, it's really hard to actually not feel excited with everything that's going on now.
Yeah, I think to me it's fun because, for example, on Dalimini, I was having fun just training it and sharing the training, the results going on and all. And there was like a few tiny user base still playing with it. There was the Discord of Dali PyTorch. People would play with it, and suddenly it exploded. And I had that tiny demo that people could just toy with, and there was maybe 10 users on it, me included, and and my friends. So, and suddenly it became so big that the demo couldn't handle the traffic anymore, and the focus moved from training these models to serving them. And I think it was cool to see that, like I was excited on it by myself before, and seeing that other people find that it's cool. It's always nice. It motivates you more to into building these models. So
Yeah, I would echo that by saying there's something really special happening here in what's happening in AI. The developments in the last few years, it's really astounding, and it's really pushing software to do things that we never thought were possible. So the idea that you can write a sentence and have a model create an image for it, or write a full essay, or understand things is something if you were building software 5 years ago, you'd think this is the closest thing to science fiction. So there is definitely a lot to be excited about. A lot of that is very applicable and, let's say, directly related to products that can be improved in the market, but also completely new categories that are now just arising on top of these models. We can get into some of these features, but also new sub-industries based on uh, large language models. But there's a lot happening on the text side. Search is, for example, one area where that's directly sort of feeding into products. Um, a lot of excitement around text generation. But if you're in a media company, if you're in Disney or Pixar, and you see things like Dali Mini or Midjourney, it's hard to think that this is not going to change your business, and machine learning is not going to be at the center of media production in the next 2 years.
Yeah, I mean, we obviously all have a vested interest in the hype playing out, but I would echo you all. It does feel very special, and I've been in this space for 15 years, so that's saying something. Jay, you mentioned kind of novel use cases and things that are now starting to happen in this very new world of LLMs. I think it'd be helpful to hear maybe some specific industries, such as say like marketing folks is an obvious one, but I think we'd be interested to hear maybe more interesting use cases or how people are using these models in ways that maybe we didn't originally expect them to.
Sure, yes, absolutely. So anywhere, any pipe where data flows and software does things with text, these models are enabling the software to do things that it wasn't able to do before. A lot of that is, categorizing and classifying text. A lot of it is grouping and allowing people to explore vast amounts of text. And that applies across industries. So if you're in marketing and you have 100,000 tweets coming at your brand, and you want to cluster and see what are the sentiments of people, what are common themes. That's a topic modeling exercise that language models improve. You can apply that to any collection of texts, let's say. So that's a little bit more on, let's say, language understanding. And there are things in text generation where it's where these new industries are coming. So a lot of these AI writing assistants, that's an industry that did not really exist before generative text models. So companies like Jasper and Copy AI and Hyperwrite, for example, that's an entire new industry that's sort of based on these generative models. And so you'll see anywhere where there's an abundance of text, a lot more tasks can be automated there. A lot of it can be just by taking the software to the next level. So things that are routine that humans do, software would be able to, assign a tag towards on, let's say, tickets based on their content, assigning them to the right person or to the right department or forwarding them to the right. So there's a lot of interesting future potential on the text generation side and new industries happening there. But on the text understanding side, that's where also a lot of the more reliable, robust use cases that are proliferating in industry at the moment.
Yeah, I for one hope Siri gets better. It seems like it should be better.
You would think so, yeah.
Yeah. All right, Boris, what are some of the biggest challenges that you faced, like in developing these much larger models, and how have you addressed those challenges?
Yeah, so the first one I had is like when I trained Dali Mini, actually I was surprised that it worked. And I got very excited seeing that it was not making really nice images, but it was starting to make something like that resemble images, and it would work in some cases like landscape and all. So I was okay, that's going to be very easy. I just have to make the model 2-3 times bigger and train it, and becomes 2-3 times better. And so I was really, really excited. I was like, it's going to take a month or two. And what happens, like, it wouldn't train, or it's hard when you use different more machines. But also you start having a lot of instabilities that you didn't have before. And like, you have to solve them. And somehow just putting more parameters, which is, you have those memes, right? Add more layers, and you solve all the issues with that. Um, it works, but at some point it doesn't work because your model becomes unstable. So to solve it, I had to kind of go back on doing research on how do people make stable training. And there's not much literature about training large models. You have all these things about, oh, our large model of 50 billion parameters or 100 billion or more like perform has that type of performance, but you don't know that along the way they had a lot of issues, um, and they had to overcome them. And you cannot evaluate your model during training because it's so heavy, so that you need to develop another infrastructure in parallel. Like to restore your checkpoint, to test the performance and be able to track any problem that happened. And I think one of the biggest problems is like, when you have a small model, it fails. You just restart training and you do it again and you change the parameter. But if you train the large model for maybe 10 days, you cannot just restart and let me try to adjust the weight decay and see what happens. You kind of want to fix the problem, like where I'm at and can I continue the training, but somehow that instability won't happen. That becomes a new problem that before you didn't care about. You would just restart from scratch, and I'm gonna redo everything with a small learning rate. And so all these challenges arrive. So it's fun. It's fun when it works after a while.
Yeah, if I could just add there, I think a lot of the challenge that we have is that not only do we need to train these large models ourselves, but we need to build tooling to help customers reliably do it for themselves. So we've learned kind of the hard way, like it's one thing to like shoestring a bunch of stuff together and just get that darn large model trained. It's another one to try to build customer facing tooling to make it easy. And that's really sharpened our focus on maybe the less exciting parts of training a large language model, like how do you just make sure the data sample is deterministic, to your point about restarting and testing, right? Across, even if you're changing GPU sizes because you're testing, you're debugging in a smaller scale system, like how do you make sure all that is deterministic? How do you make sure evaluation is really fast? These are the kind of less exciting than talking about mixture of experts and the latest modeling techniques, but that's like the nitty gritty that gets the job done for our customers at least.
It's really cool you guys are making a product to simplify a lot of these things. It's, you kind of need a degree in DevOps and networking and all of this stuff to get these big models going. So making it more easier is going to accelerate innovation. Jay, what are some of the current limitations of LLMs, and how, as people making tools and offerings in this area, what things can we do to help address some of these limitations, or what's happening there?
Yes, so it depends on the domain. There are a bunch of different domains have, let's say, different challenges. So it's kind of surprising and also wonderful in the same time that we went from not having software that is able to speak or write language to be in the space where we're saying, oh yes, we have software that can write amazing articles, but it hallucinates. So how can we solve hallucination? So we've moved so fast beyond sort of taking that one capability for granted that machines or objects didn't really have for thousands of years in human history, to taking to the next step of how can we make this more reliable for different use cases, reducing things like hallucinations, relying on things like retrieval augmentation. So that's, let's say, there's a frontier that's happening with what is the edge of where these models sort of can be taken. There are obviously issues with the safe deployment of these models. There are a lot of discussions that we need to have about biases, about safe release of these models, about usage guidelines of the providers of these models. So there's a lot that sort of needs to be figured out. And on the image side, there's a lot of, let's say, discussions to be had about the rights of the training sets and how artists can opt in or opt out in that let's say framing. So I think these would be some of the top ones that come to mind if I scan the domain generally at the moment.
Yeah, I've heard the example of having like an LLM generate code and then have it run that code, and if that code generates errors, feed that back in and have it like fix the code. As a developer, it just makes me a little nervous when we're letting these things run code, but I guess that's neither here nor there. Hanlon, I'll throw a question over to you. How do you think about kind of the trade-offs between um, model size and efficiency, right? It seems like we could, throw just more and more parameters at these things, but obviously that has like a big cost and complexity and ability to operate. Uh, Curious what your thoughts are here as finding that kind of sweet spot.
Yeah, we address it all the time. I think the failure mode for our entire field is if we develop AGI, but one forward pass through that costs, as much as a year's, salary, right? So it's not actually deployable. Um, I think what we've learned working with our customers is that pre-training smaller domain-specific models really make a difference in changing the unit economics of inference, right? You can working with Stanford, right, we trained a model that's on biomedical data, and a smallish 3 billion parameter model that's very specific for the use case can do just as well as like a 175 billion general purpose model, right? And that really changes how you think about model size and efficiency. And that's what's really opened the eyes for a lot of our customers, like, oh, this is actually possible in production. It's not, you don't need like a lot of expertise in model optimization to be able to leverage some of these very, very exciting new techniques.
Boris, you had to scale a service that got very popular on the internet. Do you have thoughts on this, or any tricks for our listeners on how to make these things more efficient?
Yeah, it's actually tricky because when we initially it's not our background providing a service of most of the machine learning researcher. It's mainly like training a model and maybe sometimes using GPT or notebook, and it's not necessarily like providing a user friendly interface that can handle a big batch. But I think what's important when we design a model, you have the goal that, for example, for image, you want the prettiest image possible. But what's important is that those models can be used too. So even before training a model, I think it's important to see what will be your inference requirements, how fast it's gonna need to be, how much is it gonna cost, for example, for us to generate an image, and you size your model accordingly. Because you can have the best model of the world, but if it costs $100 to make an image, it's not worth it. It's the same about solving AGI, right? If it costs a year's salary, I like a lot that example. You need to definitely size the model according to what your budget is for inference, not just for training, but also for inference.
Thank God for Moore's law. Uh, Boris, how do you see LLMs impacting the field of creative arts and such as like gaming, music, literature? I think Crayon is probably most close to that world.
Yeah, so it was fun because initially there was users like a long time ago when the model was still not really good. But it was fun because people were excited that it was just drawing an image, and maybe the fact that it was bad was considered as oh, it's just doing some abstract art. But no, it's just the model is bad, right? You ask for a picture of a cat and maybe the cat is completely deformed, and like, I guess it's some kind of abstract art. And we fixed it with a better model, and people are like, oh, I preferred the image from before were better. I like the interpretation of it, but it was probably not interpretation. It was mainly the quality of the model. But what's interesting is like it impacts a bit on the entire spectrum. You have people who cannot draw like me. I'm going to use these models and they're going to make something very quickly that I can immediately use, which is really nice. Same when you need to write some article or finding a cool title or something quickly, you can use these models of something very quickly. But on the other hand, people who are extremely skilled and talented, they also benefit from it because they get a lot of ideas and maybe they use it as a starting point and then they iterate over it. And you can see that for editing content like text content. But even with images, people create an image with crayon. Then the ones that are actually skilled, they put it into Photoshop and they add lightning, they add random effects that bring it to another level. So the people who are skilled, everybody like progresses a lot. People who are not skilled progress to a like average level or maybe good level, and people who are good become like extremely good and faster at it. So it's kind of nice to see that impact.
Just a little bit on the text side. So some of the initial killer apps for text generation models were games, were like interactive text games, like AI Dungeon, for example. And there's a lot of exploration about how can characters be sort of rely on generative models and how to establish their characters and their speaking behaviors via text generation models. But I do echo Boris's sentiment that yes, while the models can create an entire thing on their own, I'm most excited about them as brainstorming tools and tools that aid creatives and help them take the next level. And if you're stuck with a blank canvas, maybe you can have 4 different possible starting points to start from, and then the human sort of guides that creative process. That's, to me, is an exciting area for this.
Yeah, for sure. There's also a lot of very cool stuff happening with music lately, which has been very cool to see. Hanlon, as this space continues to evolve, specifically, these large language models, the way I kind of think about it is if I were a company that wanted to incorporate this technology into my organization, I kind of have 3 options. I can use an API and just give it kind of one shot or 0 shot learning prompts to have it do what I want to do. I could use an API and fine tune that model, or I could manage the whole stack myself or with the help of companies like Mosaic. Where do you kind of see this space going towards, or what are your thoughts as to kind of where the enterprise is going to put their money?
Yeah, I think eventually all 3 might coexist inside these same enterprises. Many of them maybe for data privacy reasons or model ownership, or they're working with like unique data, like tax compliance data or genomics, right? They're gonna want to train their own models and own them. But then for other same use cases inside the same organization, it would be advantageous for them to be fine tuning via amazing APIs like Cohere. I think for us at least, we see a lot of enterprises gravitate towards sort of the model ownership and the unique data that they have, and wanting to be able to pre-train their own models there, and seeing the ROI for that.
Yeah, I'd say, in our experience selling to enterprises, the data kind of leaving their networks or silos is often a non-starter. So having ways to do this on premise is definitely something the enterprise wants badly.
Yeah, absolutely.
Any other folks wager a prediction on which of the 3 methods will turn out to be the most popular, or how it's going to pan out?
Yeah, I do echo the same sentiment. With these models, domain adaptation is one thing that's, for example, needed. So if you're a company in, let's say, the legal space, your models would benefit by being optimized for the language that is used in that use case. That has been a common method of boosting the performance of these models. And the more tooling that you have to be able to experiment quickly, and the easier fine tuning is, the more ability to run a lot of experiments. Because at the end of the day, you're not just going to have 1 or 2 or 3 models. Systems might end up having thousands of AI touch points that would need to be sort of tweaked one way or another.
Cool. All right. This is a big, juicy question. I'll open it up to the group. With all the hype around LLMs and what they're able to do through this, statistical modeling of predicting, say, a next word, are we just like scaling these up to get to kind of human level reasoning, or the ability to kind of think about past events and predict future events? Or is there a fundamental like architecture shift? Or I know this is like very broad and speculative, but I'm curious if folks have thoughts as to, is the transformer the way to AGI, or do there need to be meaningful like advancements to get to human level kind of reasoning?
The one thing I'd say is that we are able to get this far using predict the next word is absolutely surprising. And the closest or the most impressive I've seen it deal with reasoning is something like Google's Minerva, that is able to solve mathematical problems using a generative model that's fine-tuned on that data set, and then using advanced prompting techniques like chain of thought, scratchpad, so that we have these methods that are able to do that just based on these base models. uh, I think nobody expected that we get this far using these models. uh, is just the transformer, is it just scaling the models and the data sets? um, Most likely I would say there's probably a need for more um, components, but that can be one of the components that creates or makes these future um, models that reason better. Um, but definitely things that would help are things like embodiment and the ability to interact with the outside world and sort of learn from these interactions and their um, consequences, and then potentially also social interaction with people, and that's, say, a more complex horizon. There's a great paper that deals about these. They calls them world scopes. That includes embodiment, multimodality, and then social interaction.
I think I'll just say, like, I think as a former computational neuroscience, I would be very disappointed if the transformer architecture is sort of, the equivalent of, like, what is it, like Fukuyama's, like, end of, of political governance, right? If transformers is that equivalent, like, there's so much intricate structure in the human brain that requires to deliver this type of intelligence. It would be disappointing for me. On the other hand, there are sort of theories that say, like, the retina, right, the sophisticated visual processing we do was evolved on the basis of being able to predict the next pixel, because that is essential to human, to animal behaviors, to be able to predict what's going to happen next in the pixel space. So uh, both sides are coming out of view. It's very exciting to see how this evolves over the next 5-10 years.
Yeah, I feel very grateful to be living in this time. I can't wait to see what's next.
I think there's actually still probably a lot of tricks to be found. Like we have like very basic building blocks in the end, like linear layers and a few non-linear functions. It's like very very simple overall what we use, and attention changed a lot of things. And I think there's some other things magical that are going to happen, like whether on the architecture maybe or the optimizer. The optimizers are still maybe a bit rudimentary, and something that can make a big difference. What's fun a bit and a bit sad at the same time is people try to optimize a lot the architecture, and as we get more compute power with the evolution of GPUs and all, we think, oh, okay, training becomes cheaper, but it's not really what happens. What happens is people use immediately that to make bigger models. As a GPU becomes like twice cheaper, like nice, I can make models twice bigger. So it actually evolved a bit in that direction, and somehow that what works the best. Just scaling up the model has the biggest impact often. Um, like the OpenAI models often are still like a simple GPT old architecture, and they work like perfectly well. And so it's almost a bit sad. It's impressive and sad at the same time that it works so well with no magic trick behind it. But I think some other tricks will make an impact, like attention did.
Very cool. All right. Final question, team. I'll start with you, Hanlon, but we can kind of go around. For the folks watching today's panel, what advice would you give to someone who's potentially looking to get started in AI or LLMs? And what skills do you think are going to be most important to be successful in this kind of new and emerging field in the years to come?
Yeah, when I started first in the ML space, I knew no Python. I had done my PhD in MATLAB, of all languages. Um, so I think what I've learned is that skill set wise, like, just good software engineering skill and dogged persistence is much more important than, like, being a genius researcher, or coming with some fancy new theoretical technique. Like, training these models can be extraordinarily difficult, and a good software engineering base is what I would advise. I think what's amazing about this field is that, especially, with this panel assembled, is that there's so much amazing open source tooling and educational, material out there that I've talked to folks who come from non-traditional backgrounds, so have made very immense impacts in ML just because of the accessibility of that. So just get started and dig in. There's nothing, there's no coursework you have to take to hold you back, right? It's get in, tinker, learn, and build. That's really the best way to do it, and that's very exciting to me.
Jay, any advice for the folks?
I think that aligns with exactly what I was going to say. So definitely find something that excites you, get curious, follow your curiosity, and then build in public and share what you know. So, Boris is definitely one of my heroes for building all the incredible things that he's built, but also sharing them publicly and sharing the learnings publicly, and giving ability to thousands or millions of people to try tech that was not accessible outside a couple of labs when some of the models that he released were outside. So definitely learn in public, share, don't be held back by imposter syndrome, or there's value in a lot of the content and educational, and even if you just curate the resources that work for you to learn from, that's a valuable sort of value add. And we're all learning from each other, and machine learning is absolutely exciting field that everybody collaborates this way, and it's been absolutely inspiring to see all of this collaboration.
Yeah, I would agree with that. There's so much good content nowadays online that often I guess like if you want to start in machine learning, people will probably start looking at, and I probably did that. Like, what's the best ML course? What's the best ML framework? Honestly, it doesn't really matter. They're all really really good. What matters is just starting. Like, find some subject that interests you and just try it out. Try to run it. Try to tweak it based on what you want to do, and they're all great. There's no bad answers. So.
The only thing I'd add is I would say use weights and biases, but I'm a little biased. Well, cool guys, it's been lovely chatting with you all today. Also, I did want to give a shout out to ChatGPT for providing some of today's questions. Actually, it was very good at generating questions for the panel. So if anyone out there needs to moderate a panel, use an LLM. And with that, we'll say goodbye. Thanks, everyone.